Every time you press a key on your keyboard, the letter appears almost instantly on your screen. It feels simple. Just one press, and the computer immediately responds. But behind that single keystroke, an incredible chain of events has already begun. As the key moves downward, it presses a tiny mechanical switch hidden beneath the keycap. That movement closes an electrical circuit, creating a signal inside the keyboard. This is the very first step that tells the keyboard something has happened. Inside the keyboard is a small microcontroller that's constantly monitoring every key. The moment it detects the new electrical signal, it knows a key has been pressed. But before doing anything else, it first needs to make sure the signal is genuine. The controller scans the keyboard's internal matrix of rows and columns. Instead of giving every key its own wire, keyboards organize keys into a grid. By finding the exact row and column that became connected, the controller identifies precisely which key was pressed. Mechanical switches aren't perfect. As the metal contacts touch, they can bounce for a tiny fraction of a second, producing several rapid electrical pulses. To prevent one press from being mistaken as multiple presses, the controller filters out those unwanted signals. Now it knows you've pressed the key only once. Once the key has been confirmed, the controller generates a unique scan code. This isn't the letter A yet. It's simply a number that identifies the physical key on the keyboard. Every key has its own scan code. Next, the keyboard sends that scan code to your computer. For a wired keyboard, the data travels through the USB cable. For a wireless keyboard, the same information is transmitted over Bluetooth or another wireless connection. Either way, it reaches the computer in just moments. The computer's USB host controller receives the incoming data packet. It recognizes that new keyboard input has arrived and immediately notifies the processor. Now the operating system takes over. The operating system's keyboard driver reads the scan code. Since applications don't understand raw hardware codes, the driver translates it into a standard key event. This creates a common language that every application can understand. The operating system now decides where that key event should go. It checks which application is currently active and sends the event to that program. Only the focused application receives your keystroke. The application receives the key event and determines what it means. If you press the letter A, it prepares to insert that character. If you pressed Enter, Backspace, or an arrow key, it performs a completely different action. The application decides how your input should be handled. The application processes the request internally. It updates its own data and prepares the changes that need to appear on your screen. At this point, the computer already knows what the result should be. You just haven't seen it yet. The new character is added to the application's text buffer. For example, if the document previously contained the word hello, it now becomes hello A. The updated text now exists in memory and is ready to be displayed. To make the change visible, the application asks the operating system to redraw part of the screen. The CPU prepares rendering commands and sends them to the GPU. The GPU then creates a new frame containing the updated text. Finally, the GPU sends the completed image to your monitor. The pixels update, and the new letter appears on your screen. From your perspective, it all feels completely instant. So what actually happens when you press a key? A simple press closes a tiny switch. The keyboard detects the signal, filters out unwanted noise, identifies the key, creates a scan code, and sends it to your computer. The operating system translates that information into a key event, delivers it to the active application, updates the text, and asks the GPU to draw the new frame. All of that happens in just a few milliseconds, making typing feel effortless. The next time you press a key, you'll know there's an incredible amount of work happening behind the scenes before that single letter appears on your screen. If you enjoyed this video, subscribe to the BitFlow, where we turn complex technology into simple visual explainers. Thanks for watching, and I'll see you in the next one.